Today we discussed solving equations with the distribution property, and then this also utilized combining like terms in class, and so I will show you a couple of examples of both of those. Problem number one certainly has multiple mathematical approaches through which we could solve it, but for the sake of making you good math students that don't make mistakes, we're going to be consistent on how we teach the rule for solving this problem. So your first and best practice in order to make sure that you're consistent on how you solve all problems will be to distribute anytime you can first. And in this case, we can distribute. 3 times x is 3x, and 3 times negative 1 is negative 3 equals negative 15. And now we're basically looking at a two-step equation. My 3 is attached to the x through multiplication, so I have to do my subtraction function first. The inverse operation for subtraction is addition, so I will add 3 to both sides of my equal sign. Negative 3 plus 3 will cancel out. Negative 15 plus 3 will become negative 12 equals 3x. And now I can deal with the multiplication that's taking place between my coefficient 3 and my variable x by dividing by 3 on both sides of the equal sign. And my 3 will cancel out, so that will leave x all by itself equals negative 12 divided by 3 is negative 4. And remember how we talked about in class, you can certainly check your answers, so there should be no reason to miss these types of problems on your homework, on your quiz, on your study guide, or even on your test by taking our value for x, which we would determine was negative 4, and plugging it back into our original equation. So 3 times negative 4 minus 1 equals negative 15. And now we just simply solve the problem. Negative 4 minus 1 is negative 5, so negative 5 times 3 equals negative 15. 3 times negative 5 we know is negative 15 equals negative 15. If we get down to the point where the left and the right side of our equation both say the same thing, then we can check our solution as accurate. Now let's do one more that involves combining like terms. This one also has distribution, so that'll work out for satisfying both of the criteria through which we did in class today. So again, 3 times x is 3x. 3 times negative 5 would be negative 15 minus 6x equals 0. Now we need to look and see if we have any like terms, and I do. I have a 3x and a negative 6x. And so 3 minus 6 is negative 3x. Keep the minus 15 equals 0. Now we're down to a two-step equation again already. It doesn't matter if 0 is placeholding on the side because it's still a number. So I can add 15 to my left side. What I do to the left side, I have to do the right side, so I will add 15. That will give me negative 3x equals 15. Now I want to unmarry the negative 3 and the x. And I saw a lot in class with similar problems to this. Instead of dividing by negative 3, I would see students divide by 3 because that was the value of the number, and then just magically make the negative sign disappear somehow. You have to be very careful because that negative sign is attached to the 3. So in order to have more room, let me move over to the right just a little bit. So we have negative 3x equals 15. I will divide by negative 3. What I do to one side of the equal sign, I have to do the other, so divide by negative 3. And x will equal negative 5. Again, we can check our answer. Let me move down to a clean section on this piece of paper. My problem was 3 times x minus 5 minus 6x equals 0. So everywhere that there is an x, I will plug in this value, negative 5. 3 times negative 5 minus 5 minus 6 times negative 5 equals 0. Negative 5 minus 5 is going to be negative 10. So I have 3 times negative 10 minus, well, we got a 6 times negative 5 is negative 30. And here I have a minus and negative, which is going to change that to being positive 30. Remember that rule from Unit 1. 3 times negative 10 is negative 30 equals 0. So now I have negative 30 plus 30. If we're thinking of a number line and I start 30 units to the left and then I move 30 units to the right, that will put me at 0. So that would give me 0 equals 0. And my solution checks out. I will leave that there for just a moment because I did not realize that my page was off the screen of the camera. But again, we have negative 5 minus 5 is negative 10, times 3 is negative 30, and negative 5 times 6 is negative 30. My two negatives become a positive, so negative 30 plus 30 equals 0. 0 equals 0 is a true statement. Hopefully that helped give you a good start on your homework. Since now I have done 2 of the 10 problems, you only have 8 remaining, and they should not be that tricky for you aside from maybe those last 2, but if you take it step by step, I think you will be quite all right.